Okay, this is 6.5, Similarity and Measurement. Basically, what we're going to be doing is using the same things we learned in the last section, 6.4, and taking those a step further. This is kind of the strength of what we learned in the last section. This is where it will help us the most. And we're basically going to look at two similar shapes with each of these problems. Okay, here we have, let's see if we can get a pen here that works. Here we have ABCD is similar to EFGH, okay? So we know that these two shapes are similar. That means they're the same shape, not necessarily the same size. And we're looking for x. And with all these problems, we are going to set up a proportion defined x. So that's what we're going to do here. And so I'm going to take the information that matches. Remember, when we set up ratios that are equal, we put together information that matches. And so I've got AD here, which is 12. Okay, now AD corresponds to EH. Well, EH is here, which is 30. Okay, those two correspond to each other. And because I put this length on top, I've got to go back to this shape and put that length on top. I've got to match my data, okay? So I've got the small shape on top, large shape on bottom. Well, that corresponds to X, okay? And then what I'm going to do, I'm going to cross multiply. So I've got 12x. Wow, that's pretty ugly. Let's see. 12x equals, okay, and that's going to be 30 times 16, which equals 480. Okay, now I'm going to divide by 12, divide by 12. X equals, well, 12 goes into 48 four times, so it's going to be 40. X has to equal 40, and that's 40 inches. Okay, so we used a proportion, although I was a little off down here with my writing, and this was pretty ugly. We successfully solved this for x in these two similar shapes. Okay, and that's pretty much what we're going to be doing this whole section. Okay, let's look at this next one. We have triangle ABC is similar to triangle DEF. Okay, because we know that, we know the ratios of the corresponding sides are equal. So I'm going to start with this one, this shape here. I'm going to start with 30, and it doesn't matter which shape you start with. I can put this one on top or this one. It doesn't matter. I'm going to start with this one. Let's start with x. Let's keep x first. And if it helps you to do the same thing every time, always do that. Put x here. Okay. Now x corresponds to what length over here? Well, AB corresponds to DE. So that's going to be 35. Go back to the small one. And then I've got 35 on top here. That corresponds to 45. Cross multiply. I got 45x equals 35 squared. Let's see what that is. It's going to be, let's see, 1225. Divide by 45. And we're going to have something that looks like 27.2 repeating. Okay, so x is equal to 27.2 repeating. Now, some of these you may get, repeating decimals. Most of these, I think you should get at least whole numbers or fraction or decimals that end, that terminate. So this one, we don't need to worry about the fact that we got a repeating decimal. We'll just either round it to the 10th if you need to, or you can put the repeating bar there. And since there's no units there, we're not going to put any units on our answer here. Here we have two shapes. Again, we're going to use a ratio proportion. Let's put the x on top. Let's keep it first. Well, x corresponds to what in the small shape? Well, that's 36. Go back to the shape that x is in, 35. Remember, I have to keep the same shape on top, same shape on bottom. Well, 35 corresponds to 21. Okay, so that's 21x equals 36 times 35. It's going to be 1260. I'm going to divide by 21 on both sides. And that's going to equal 60. Like that a lot better. X equals 60. So 60 is up here. Again, remember your units. If you have units associated with the numbers, remember to put the units there. Okay, now here we have a triangle. We have two triangles, ABCD and DEC. And what you have to see is that there is a triangle inside of a large triangle. So we have this big triangle with these 3 points here, okay? And then we have a smaller triangle here that kind of comes down this way and goes this way, and they have the same point, okay? I know that's ugly. I have a hard time drawing straight with this pad. But so this is the smaller triangle, okay? And then the larger triangle is just this one out here. So we want to find x, and we're going to set up a proportion. Okay, so we're going to start with this large triangle. Now the large triangle is BC. That's a length. Well, x is not the length of BC. X is the length of BE. So what is the length of BC? Well, it's 36 plus x. Okay, now what does BC correspond to in this small triangle? Well, BC corresponds to EC. They share the base. Okay, this from here to here corresponds to this from here to here. Okay, so 36. 36 plus x and 36. Now go back to the big. We started with the big triangle first. Well, what is the length that we have? The only other length we have is 20. And that corresponds to what in the small triangle, which is 15. So I'm going to cross multiply. I get 720 equals 15x plus, let's see what that is, 540. Okay, I'm going to subtract 540 from both sides. I get 15x is equal to, that's a 0, that is an 8, that's 1. We're going to divide by 15. X is equal to, well, 15 and 18 is 1 time remainder 3, 15 and 30 is 2. X is equal to 12. So this little small length right here is equal to 12. Okay, next one. Here we have something we actually use in real life using this system of solving for x, or a length that's unknown. Here we've got a tree. Now a tree would be very hard to measure if it was a whole lot taller than you, but if it casts a shadow on a sunny day, you can take something that you can measure, maybe the snowman for instance. I can measure the height of the snowman and then see what kind of shadow it casts and compare it to the shadow cast by the tree. So the same thing, we're gonna do the same exact thing here. We're gonna make proportion. Okay, let's start with what we don't know, h. Now the height of the tree corresponds to what in the snowman? The height of the snowman. Height corresponds to height. Now we got to go back to the tree because h was first, so the shadow in that corresponds to the shadow here. Okay, now just cross multiply. 2h is equal to 30, divide by 2, divide by 2. H is equal to, that's a 30, not a 36. H is equal to 15. So the height of this tree, whether it looks that way or not, in this problem, is 15 feet. Okay, so again, I compare the height to the height, shadow to the shadow, and I just set up a proportion. Moving along. Now here I have a rectangle within a rectangle. ABCD, the big rectangle, is similar to AEFG, the small rectangle. Okay, again, proportions. So let's start with the big rectangle. AD goes with AG here. So what is the length of AD? It is 18 plus x. It's just like that problem with the triangles. Okay, I've got to put both of those there because that's the length. That goes with AG, which is 18. Then what is the length of AB? Well, it is 28. And then that goes with 21. Okay, now just to help me out here, I'm just going to reduce this fraction. 28 over 21 reduces by 7. I get 4 over 3, right? Okay, so I'm going to cross multiply. I get 3x, and remember you have to distribute when you do this. Equals, let's see, that's 60 minus 9, which is 51. Okay, and then 32, 14, 24, 72. Okay. let's see. So I've got, you multiply 3 times x, which is 3x, 3 times 18, which is 50, not 51, 54. Okay. And then I'm going to cross multiply the other way, 4 times 18, which is 72. Okay, now I'm going to subtract from both sides, 54 minus 54. 3x equals, well, this should be 18, right? Divide by 3, divide by 3, x equals 6. Okay, again, set up a proportion, solve for x. Okay, set up a proportion, solve for x. Okay, this is as hard as they get. This will be the last one we do. I think, let me check the next page. It is. Okay, we need to get rid of this because this is not helping us. There we go. So let's solve for x. Okay, notice we have let's see if I can get a different color here. We have a small triangle, and it didn't give me a different color, did it? There we go. Then we have this medium-sized triangle that kind of extends over here. Then we have this big triangle that it extends that way, and I'm going to erase those, but I'm just going to show you. We have a triangle within a triangle within a triangle, and it's hard to see sometimes, okay? But notice this small triangle right here, I've got all the side lengths for, and I'm going to use that for my proportion, okay? Now, let's just say we want to find x. Well, let's go with a small triangle because that has all the information we need. What part on the small triangle corresponds to this? Well, this part right here. It's obvious. Okay, this corresponds to this. So I've got 3 corresponding to x. Now, let's go back to the small triangle. I do have this length on the medium-sized triangle, which is 4, and I've got this length, so I'm going to use this side down here. Back to the small triangle, that is 4, and that corresponds to this entire length, which is not 4, which is 8. Okay, it's this plus this. Okay, so 4x equals 24. That means x is equal to 6. Okay, and if I wanted to find y, I could do that the exact same way. Got a ratio. Let's start with the small one. 3 corresponds to y. So 4, let's use that bottom one, corresponds to 4 plus 2. That's going to be 10. Okay, that means 30 equals 4y. Divide by 4. Y is equal to, let's see, 4 into 30, that's 7 times. That's 7.5. So this would be 7.5. Okay, I'm not going to find all the lengths, but if I were going to find W and Z, same way, I would use, for W, I would compare this to this in a ratio, 3 to 6, and compare this to this whole length, which would be 5 to 5 plus W. Okay, then I'd cross multiply, 5 times 6 is 30. Okay, then I've got 3 times 5 is 15 plus 3W. So I subtract 15 from both sides, divide by 3, and I would get 5. And that makes sense because this is 4 and this is 4, they're equal. This is 5, they're equal. Okay, and that is all for today.